Okay, so let's continue with limits. So let's say I want to find the directional limits limit xy approaches 0, 0, given that x equals 0, that's the y-axis, xy over x squared plus y squared, and I want to find the limit as xy approaches 0, 0 along y equals 0 of xy over x squared plus y squared, and I want to find the limit as xy approaches 0, 0 of xy over x squared plus y squared as x equals y. So along the line x equals y. And then find the directional limits. Can you say anything about the limit as xy approaches 0, 0 of xy over x squared plus y squared without a direction on there? So we're going to find these three directional limits and then see, does that tell us anything about the limit? So for this first one, we start off by putting in x equals 0. So I'm going to take the limit as xy goes to 0, 0, and I have 0 times y over 0 squared plus y squared, and that gets me the limit as xy approaches 0, 0 of 0, because 0 times y is 0, over y squared, and that just equals 0. So just as a little aside, if I'm taking the limit as x goes to 0 of x over any limit as x goes to anything, so anything, of 0 over something, where this isn't just an actual 0, just the number 0, that's 0. So the limit as x approaches 0 of 0 over x, that's actually 0. That's not undefined, because 0 over x is just 0. So when you have the limit as x approaches 0 of a number over x, so 0 is in the denominator. If I take the limit as x approaches 0 of a number over x, that's going to be either plus or minus infinity. If this is a positive number, it would be positive infinity. So limit as x approaches 0 of 1 over x, that's positive infinity. The limit as x approaches 0 of negative 1 over x, that's negative infinity. So a number over 0 is infinity. If I have the limit as x approaches 0 of x over x plus 3, that gets me 0 over 3. If I have 0 over a number, that's just 0. So 0 in the numerator and a number in the denominator is 0. 0 in the denominator is infinity. But if I have actual 0, like I have here, that just plain equals 0. Okay, so now let's do this one. This time we're going to let y equal 0. So I have the limit as xy approaches 0, 0. And I'm going to let y equal 0, so that's x times 0 over x squared plus 0 squared or the limit as xy approaches 0, 0. And again, I get 0 over x squared. 0 over x squared, that's just 0. So that exists, so that's just fine. No problem there. So it's looking like it would be 0. Well, let's try this last one. This last one says x equals y. So I take the limit as xy approaches 0, 0. And this time I'll let x equal y. So I'll have y times y over y squared plus y squared, because I replaced x with y. That gets me the limit as xy approaches 0, 0 of y squared, y times y is y squared, over y squared plus y squared is 2y squared. The y squareds cancel, and I get the limit as xy approaches 0, 0 of 1 over 2, which is 1/2, which does not equal 0. And so what we can say is that the limit does not exist. Okay, so now you try this one. And so investigate, let's see, so find the directional limits. Limit as x approaches, as xy approaches 0, 0. X plus y over x minus y along x equals 0, and the limit as xy approaches 0, 0 along y equals 0 of x plus y over x minus y. So try those and see what you get. So pause it and see what you get. Okay, so for this first one, we replace x with 0, and I get 0 plus y over 0 minus y, or the limit as xy approaches 0, 0 of y over minus y. Well, anything over itself is 1. Anything over the negative of itself would be -1. So it'd be the limit as xy approaches 0, 0 of -1. There's nothing to plug in there, that's just -1. So now we're going to approach along y equals 0. So I'll take the limit as xy approaches 0, 0, and I plug in 0 for y. And I get x plus 0 over x minus 0. So that's the limit as xy approaches 0, 0 of x over x. Well, anything over itself is just 1, and so this is the limit as xy approaches 0, 0 of 1, and 1 does not equal -1, so the limit does not exist. All right. I don't know if, because I don't have lecture 12, so I don't know if y'all did continuity, but continuity, first thing about continuity, all polynomials are continuous everywhere. So if all you have are variables raised to powers and you don't have any fractions, you don't have any square roots, you don't have anything to worry about, it's continuous everywhere, is f of xy equals 3x to the third y squared minus 2x squared plus y to the fifth. Continuous, and I could say continuous at a certain point, so at 0, 0, or I could just say, is it continuous? It doesn't matter, it's a polynomial, it's continuous everywhere. It's a polynomial because there's no fractions, there's no square roots, there's no logs. So the answer is yes, continuous everywhere. Let's take the function that we just looked at right here. Let's say x plus y over x minus y is f of x plus y equal to x plus y over x minus y if xy does not equal 0 and 0 if xy equals 0. Is that continuous at f of xy equals 0, 0? And because we just did this one, we know the limit as xy approaches 0, 0 doesn't exist. And so we can say no, because the limit as xy approaches 0, 0 of f of xy does not exist. So if the limit doesn't exist, then it's not continuous. Okay, so let's move on to partial derivatives. Partial derivatives. So partial derivatives are where you take the derivative with respect to just one variable. So you have a multivariable function, but you're taking the derivative with respect to just one variable. So and you treat the other variable as a constant. So if I have f of xy equals x to the third plus x squared y to the third minus 2y squared, find, and there's different ways to write this. You can write it as, that's a df dx, that's a little curly d there. Find df dx, that's the partial of f with respect to x. So the partial derivative of f with respect to x, or you can write it as fx with a little x underneath. So you just go through and you differentiate it, and you just treat y as a constant. So you don't do anything to the y. The y is just a constant, just like if it was 5. So the partial with respect to x would be 3x squared, and then plus 2x to the first y cubed. That y cubed is just a constant, it just multiplies. And then minus 0, because y squared, you treat it like a constant. Find the partial with respect to y. So the partial with respect to y, the derivative of x cubed is 0, because we're going to treat x as a constant. And then x squared y cubed, that would be 3x squared y squared minus 4y. So you just differentiate the one that you are looking at. Okay, so you try find fx. So find, and this looks like the way he's writing it, the partial of xy with respect to x and the partial of f of xy with respect to y of f of xy equals 4 minus x squared minus 2y squared. Alright, so the partial with respect to x, you treat y as a constant. So 4 is a constant, so its derivative is 0. And then I have minus 2x, and y is a constant, so its derivative is 0. The partial of f with respect to y, I treat x as a constant, so derivative of 4 is 0, derivative of minus x squared is 0, and I get minus 4y squared. Let's see, what do we have here? I have to stop here for now. I may continue this and then another one.